Okay, hello all. Uh, Welcome to another data science with Julia video. So today we are going to continue the statistics. Hopefully, I'll be able to complete in this video. So yeah, let us see it. So in last video we saw till mode. Okay, so like mode means whatever is the maximum number of values that's occurring in a vector that will be returned out as mode. So here it is one, so it has been returned as one. So there is another good measure of statistics, like percentile. Like let's say like your earnings is like 50,000 per month or something like that. And to say that you are in the 99th percentile of earning in India, possibly it is true because like a lot of people get less than 50,000 per month. And what we people having computers in India earn is far, far, far higher than what an average Indian earns. Okay, so if you just share like you are more than 99, the top 1% of earning Indians, or possibly you're the 98th percentile or something like that. Uh, yeah, that might be true. Like, what to say? Yeah, so yeah, that is the thing. That means like below you, like there is 98% of India. Okay, so something like that. So that's what 98 percentile mean. And so yeah, let us we just code a function for percentile. Yeah, before that, let me just launch my editor and all those things. Okay. Okay, right. Check the lab. Okay, let me just go on to stats. This is median mode percentile. Yeah, so we have just coded a function over here. So, okay, so let me just have what to say, right? So, okay, so you just have this vector 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what you also have it over here. So 1 to 10. So what is like the 58th percentile? So what is the 50%? So the 50% will be something over here from this to this. So what is the maximum value over here? It's 5. So this is the 58th percentile, right? So that is like the 50% of values. Okay, so there are 10 values, the 50% of values over here, like 5, right? So that's the maximum percentile. Okay. The 75th percentile is, yeah, somewhere between the 7 and 8. Okay. So the maximum value over there is 7. So this one gets returned. Okay. So 7 gets returned. So this is what percentile is, and it's been coded by a very simple formula. So you just, what to say, uh, give the percentile as p, and you just pass a vector v, and it is just like you just truncate like what to say, p into percentile, and p into length of vector, and then you just return it. So that's the thing. So yeah, this is what percentile in statistics is, and there is a thing called interquartile range. Okay, so the interquartile range is nothing but like, okay, like you take the percentile, okay, and you just get the difference between the 75th and 25th percentile. So what is quarter? The quarter starts from 25, 50, 75, and 100. Okay, so you just take the thing between like what to say, 25 and 75. So that is the range. So this is the range between 25 and 75. So that is called as interquartile range. So let me just what to say, explain it like more like okay, candle chart. Okay, so if I just put candle chart, I'll get a Wikipedia article. So okay, right. Okay, not this one, but okay, but okay, it is showing in this one. Okay, not this one, but okay, 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 okay. But yeah, you can. Okay, just for now, yeah, I'm just. Oh God, why it's going to Amazon? My God, Amazon is just everywhere. It's just spamming us like anything. I think YouTube has also become like a spam thing. A lot of ads. If we don't allow ads, we don't get money, so we have to allow ads. So okay, just imagine like okay, like you are just this is the zeroth value, this is the 25th percentile, this is the 75th percentile, and this is the 100th percentile. This is actually not like okay, don't think as stocks, okay, think as graph where zeroth percentile, 25th percentile, 75th percentile, and 100th percentile. The stuff between the distance between this one, the 25th and 75th, is called interquartile range. Okay, actually, Khan Academy has a very good explanation of it, but yeah, like I'm very lazy to go to Khan Academy, search it, and show it, right? And yeah, next is variance. Okay, so variance is some kind of measure like how much your data varies. And it has been given by this formula, sigma square and all those stuff. Okay, so like how much your value varies above or below mean. Okay, so like this is the mean, and I hope you can see it. Okay, so if this is the mean, and if your value, okay, let me just put my OBS and see whether, okay, this is the mean. Okay, yeah, I think you should be able to see it, right? Yeah. So this is the mean. If the value is above, then the distance is so much. Okay, and even if the value is below, okay, then the distance is still so much. Okay, so how to what to say? Get the absolute value or something like some kind of measure of absolute, okay, so that it should not be negative, because if the value is so much and the value below so much, the next value is so much shouldn't cancel out. So what you do is like you just square it, okay, so and you just divide it by the number of samples, that is the n, and that's called as variance. Okay, so there are two kind of variance. One is this is the population variance, that is, let's say like you measure height of all plants in a nursery, so that is the entire population. Okay, and so then you just divide to get the variance, you just compute the mean and you just divide it by n, that is the number of plants, like say if there is 50, what plants shall I say? Tomato plants? Yeah, tomato plants do grow to some height. Okay, so that's the thing, and that's the thing. Or rose plants. Okay, so that like okay, a lot of people know about rose. Okay, so yeah, fine. So that is it. Like if you have 50 rose plants, that is it. Let's say you are only measuring like 10 rose plants and you want to calculate the variance. This is called like sample variance, and for some reason you divide it by n minus 1. Okay, so that's the thing. And in fact, like sigma of some value by some number and total sigma of some value by some number is both the same, right? Okay, so you can just take this n minus 1 out and you can just what to say, it becomes then sigma of x minus x bar and by n minus 1. Okay, so X bar is nothing. We say it like what to say, sample average. Okay, so like out of 50 rose plants, you're only taking 10 rose plants out and measuring. If you take all the rose plants like 50 and you just measure the what to say mean of it, what to say, like that is called as X bar is called as sample mean, and mu is called as population mean. Okay, so that's how it is. Okay, and yeah, don't ask me why is n minus 1. Like I just went to it, I'm understanding at the time, but I'm just no, it's not retaining for me. So yeah, so we just what to say, coded a function called variance, and we just pass in a thing called kind, and if it's population, it returns the population variance or it returns the sample variance. Okay, so that's the thing. So that's the variance, and we have just wrote a function. Both are same. Like instead of n over here, that is over here, it just gets divided by n minus 1. So that's the thing. So what we are just doing is okay, we are just finding the n, that is the length, the total number of samples in a vector, and what to say, why do we put x is equal to v? Okay, for some reason we are putting x is equal to v. I think I'm putting x is equal to v so that because it's very easier to say, okay, because over here we are just saying it as x, right? So if I put x, it'll be easier for me to write the code. That's it. And mu is equal to mean of v. I should have put mean of x. Okay, and mean difference is okay. Okay, like x minus dot mu. That is like for each and every element. So that's why we are just putting that thing. And square mean difference. Okay, so square of mean difference. Okay, so this thing. Okay, square of mean difference. So this thing. Okay, so that is the numerator. This thing along with the 2. Okay, so I'm unable to select, yeah, that thing, right? So that we are just finding it over here. That's nothing but mean difference square, and this also we are squaring each and every element. Okay, so that's the thing. And next we are just summing it up and dividing it by n and returning it. Okay, over here it's just n minus 1. So still like these two formulas, what is it? Yeah, I don't want to confuse you. Yeah, for what is it? Sample variance is n minus 1, and for population it's n. So we are just calculating. Okay, so population variance we are just calculating, and variance also we are calculating. By default it's population variance. Okay, and yeah, we are passing population over here and we get this output. And what to say, sample variance, okay, we're just calling this function. Okay, we can, and now in this okay, variance, we are passing this thing called sample. If you pass anything other than population, it is going to give sample variance. So that's it. So we are just passing it sample and we are just getting sample. So there will be some kind of difference. Okay, so okay, like actually this is kind of rigged up example. I'm not happy with that. Okay, so you have the sweet count. Okay, so what you do is like we just do the variance. So this is the what to say, population variance. So for the entire stuff, and sample sweet count we are doing some variance. So we just took some variance of samples and that we are just doing. Okay, so that's the thing. And now we just put this variance of sample. Okay, so that's the thing. So it won't come. Okay, this samples count. Okay, so when we do the variance, okay, it is coming to 9.48. That is far difference from 10.78. Okay, so that's the thing. But when we do the sample variance for this one, that is nothing but a sample of this thing, sweet count. Okay, right? It is coming to 10.84. Okay, which is very near to this one, like 10.78. That is the population variance. So there seems to be some kind of truth over here, but don't ask me why. I don't know why we are dividing it by n minus 1 and all the stuff, right? So yeah, now let's go to standard deviation, right? Okay, so standard deviation is nothing but, okay, like variance, okay, like it is some kind of number, like you have square, like let's say you are measuring the height of rose plants. So the dimension will be, what to say, let's say we are measuring it in meters. Okay, so so the dimension will be meter square. N has no dimension. Okay, so the variance doesn't correspond with the dimension of measurement. Okay, so we need to get some dimension of measurement. Okay, so what we do is like we take square root of variance, and what to say, like that gives us standard deviation. Since there's two type of variance, okay, like what to say, like mean variance and population variance and sample variance. We have two type of standard deviations. One is for population, denoted by, what is this Greek letter? I forgot. Like it's sigma, right? Yeah, it is called sigma. It is lower sigma. Yeah, so this is lower sigma, and what to say, sample standard deviation we give it by S. Okay, so that's how it is. So yeah, we are just doing this standard deviation. So this is the formula, and over here the variance is equal to, okay, if the kind is population, we get it as population variance. If you haven't seen this concept, yeah, this is a way to construct Julia programs and even other programs. You just put variance is equal to and the condition block over here, right? Okay, so this just picks up, this variance picks up whatever that's been returned out of the condition block. So if the kind is population, we get population variance or sample variance and assign it to variance, and then we just return the square root of variance. So that's how it is. So yeah, once again, we do the sample deviation of standard deviation of the entire sweet count, and we take sample sweet count, that is number of sweets distributed to people in class or something like that. And yeah, it kind of matches. Okay, you can say it as 3.3 and this is like 3.4 and kind of matches. Okay, so let's say like you have two vectors. Okay, so and you want to see whether uh, okay, let's say like, okay, a vector, first vector is there, its first value lies above mean. The second vector, let's say call it as y vector, its value also lies above mean. Okay, and then during the second iteration the x goes down and y also goes down. Okay, so what to say, so that is like x becomes more negative than mean and y also becomes more negative than mean. So they both vary together, so this is called as covariance. Okay, but if x goes below mean and y stays above mean, then there is no covariance. That is like it's very less. Okay, so they don't vary likely. Okay, so that is called as covariance, and it has been defined by this formula: I is equal to 1 to n x minus x bar y minus y bar divided by n minus 1. I don't know why n minus 1 and all those things. There is no sample and population over here, so it is just n minus 1, right? So that's how it is. And so that's what we calculate over here: x mean and y mean, and the difference between the, okay, this is the x mean and y mean, those are all means of x and y. Now we take the difference, note like we just do element wise operations over here, okay, and then we just get length. Okay, we assume that, okay, both x and y's length are same. Okay, so that's the thing. And now what we do is like we just multiply each and every element, like, okay, x is 1 into 8. Okay, x is over here, y is over here. 1 into 8 plus 3 into 6 plus 2 into 9. That's what this one does. Okay, first it does the multiplication, then we just sum it off. Okay, so that's how it is, and then we just divide it by n minus 1. That is the length minus 1. So this is called as standard. Sorry, this is called as covariance. I'm really sorry. Right. So this is called as covariance. So like this one doesn't have any covariance. Like this one, just if x varies in one direction, y may vary in another direction. That is below or above the mean. So this doesn't have any covariance, whereas this has more covariance. So this is more positive number, and this is negative number. Okay, and this can go to any value. Okay, it can go very very less, very very high, and all those stuff. Okay, there's very very less in the minus, or very very high in the plus, and all those stuff. Okay, okay, covariance, it is just a number. You can only do relative comparison. But what if you have something like, look, if two things are not at all correlated, two vectors are not at all correlated, right? Then if we have, if it goes to minus 1 when there is completely no correlation, or if it goes to plus 1 when there is complete correlation, that will be a very good measure. Okay, so it happens, so like, okay, the correlation, I'm putting it as CRR. I don't know what is a real sign or something like that. It's nothing but covariance of x and y divided by the standard deviation. That is like population standard deviation of x and population standard deviation of y. Okay, so sorry, not population. That is the sample standard deviation of x and sample standard deviation of y. I don't know why it's not population. It's only sample. That's because, like, okay, we are dividing it by n minus 1. Okay, I actually theoretically I should be going into so deep into statistics, but yeah, it's taking so long. Like, so like give me some, what to say, pass over here, right? So, but the thing is, like, yeah, sample standard covariance of xy divided by its standard deviation of x and y. Both are like sample standard deviations. Okay, so that's the thing. So correlation is very easy because we have already written the covariance, and so we are just dividing it by standard deviations. That is like, that's the thing, and we're just getting it. So we have got these two vectors over here. So, and we are just doing the correlation, and comes to 0.98, very highly correlated. So if you look over here, like what to say, okay, where is this covariance? Yeah, so it went to positive over here, but over here it's coming like 0.98. Okay, so very high covariance. Okay, and if you take like x and y, this values that had like negative covariance. Okay, so, and it says like and if you just pass these same values to correlation, it says like it's 0.9, minus 0.91 or something like that. So like this is very good measure, like between minus 1 and plus 1. So similarly, yeah, you can do it in natural language I'm sorry, natural language processing or something like that, and all those stuff, like counting the number of words or something like that, then ordering it, and then seeing like whether two documents are what to say correlated to each other, and all those stuff. So I've given some links in my what to say book and all those stuff where you can explore further. So this is what concludes statistics. Yeah, I might be updating my book with something more and all those stuff, but I'm not sure. Next, I just want to go to matrices and probability, and yeah, I've done something in matrices. It's there, and what to say. And that's the thing. And I think like even in my previous video, I've given the link for his Jupyter notebook. I'll also link it in this video. Anyway, have a nice time. Let's meet in next video.